And you were saying something.
Yes. Last Friday, you want me to remind you about the setting, the curly bracket with
Oh,
A
here.
in the
Okay,
class.
sure. Okay. All right. So it just doesn't want to go away. Get out of my. Okay, there we go. So we created this validated int last time, okay? And we created a constructor that gets an integer number over here as default value, right? If you didn't want to do that, if I wanted to have, for example, in here, where is the thing? The source code for it. Let me split the two. So say I don't put the default value over here, and I want to have default value to be set in another way. What you can do is this. So I can make the default constructor. One way is to actually create the validated int, okay, and actually implement it and do the string copy in there, okay? So I could actually implement that thing and do a string copy. So if the people don't put anything over there, it does whatever it's supposed to do, okay? But another way is to setting this to default. Essentially means you're asking compiler to create an empty no argument constructor. So by doing this, the compiler will create an empty one for you, as if you created it in a CPP and left the body empty. Now, if you put any default values over here in any way, either do a universal one, or you say int value is 0, or universal one, or in here you set to mtitle is to, what was the default thing that we said over there and I removed? Integer number?
Yeah.
So by doing something like this, essentially you are telling to the compiler, I want those things to happen before any construction. Which means in your constructors, like invalidated int over here that I have with one argument, oh, I'm actually setting it using initialize, which is fine. But if I didn't, it doesn't make any difference. So yeah, if I did that, it wouldn't make any difference. It would work perfectly anyway. Okay? So it means before any constructor begins, these values are set. Okay? And there is actually another way to do so too, and we'll talk about it later. It's not important now. Okay? But just remember, you can initialize the values either using universal way of initialization or actually set it to something if you want to, as you saw I did it over there. Okay? So title will be automatically integer number and so on and so forth. Are we good? Okay. That's that. So a quick review on what we have done over here. So essentially we said that when we are dealing with operators, we have two major type of operators that exist out there, and they are binary and unary. Exactly. They are either binary or unary. I see Jacques is not here. Darian? Lance? Again? Aryan? Kushal? You're here? Please look at your name. Isa? Wow. Lindbergh? Ali? Mutasim? I'm here. Ahmed. Holy shit. Fancy. Min?
Right here.
Okay. So now, when we said we are dealing with binary and unary operators, each one actually goes to two separate categories. Do you know what those were? Like when you are designing a binary operator can be either this or that.
Which can have side effect or cannot. Have
Exactly.
side effect.
All operators can be either no side effect or with side effect, which essentially means after the operation is done, either the operands change or they don't. Okay? So we're good with that, right? Tina. So how do we enforce no side effect? Do you remember?
If it's also const, if there will be any side
You said what?
If it's in const.
That's it. That's all you needed to say.
Yeah.
So we enforce no side effect by making the operator overload implementation a constant and the argument constant. Okay? And if we don't make it a constant, it's always a possibility to either change the owner or change the argument. So the owner is, you're here? Nope. Shaval? All right. So when I'm creating a member operator, do you remember the owner being left operand or right operand?
On the left.
Left operand. So the owner is always the left operand, and the right operand is the argument we pass to the operator overload. If it's a unary operator, the owner is always the operand. There is only one operand, either prefix or postfix. Okay? Here? Anyone? You're here? No? Khan? All right. So last time we missed your thing, right? Okay, so remind me to fix it today.
Oh, I did send you a message.
You sent me a message on Teams?
Yeah.
Okay, fantastic. So I'll take a look at it. All right. But anyways, I'll fix it over here too. It doesn't matter. So what was the question I wanted to ask? I had a beautiful question. Oh, so we have prefix unary operators and postfix unary operators. One of these two is exceptional. Which one it is? Prefix or postfix? Which one happens more often, prefix or postfix? When you are creating a unary operator comes before the operand, right?
Yeah.
So prefix is most likely happens or postfix?
Prefix.
Prefix, exactly. So when you are writing a unary operator, it is mostly prefix. We only have two postfixes. Rosham is here? Oh, there we go. Sorry. Sorry, I'm bad with names. So we have only two that can be postfix. What are those two? Remember? Only two operators can be prefix and postfix. None of them can be postfix. Only two of them can. Do you remember?
Is it plus and minus?
Plus plus and minus minus. Exactly. It's plus plus and minus minus. Only these two operators can be postfix. None of the operators can. Only these two. We good? All right. Alan? Here? All right. Kiarash, because the signature of unary operators is always owner dot operator, how do we specify that this is a postfix not to have a confusion? Do you remember? When you create, you actually see it over here at line 28. So when we want to make sure it's postfix, we have to add a flag. That flag is the int that we add. So the int that we add over there it actually specifically tells us that this operator is postfix. It has nothing to do with an integer argument. It's just the flag that this one is a postfix plus plus operator. We good? All right. Abdul? Kyle? Razeen? All right. Your name never came up. Your name is? Huh. I don't know. We'll see. Check your attendance. See, not now, but later when I upload it. Tell me what's going on. Okay. All right. And let's start our session. Okay. So we have done all this thing. We created these operators, and they're all nice and beautiful. Nothing's wrong with them. But there are certain scenarios that it makes it impossible for us to actually overload an operator. Okay? First of all, I'm going to remove one of the operators over here that's going to cause an exception. I'm going to remove these two for now. Actually, let it be. Let it be. Let it. I'm trying to think. Okay, so let's actually do it. I'm going to write a few things over here that is not going to make sense when you're actually writing the code. And we want to see how we can actually fix these things. Take a look. If in my main, oh, and I don't have a main. Add new item. Actually, let me bring it from another one over here. Someplace that we have a main with those things. This was the one, and let's copy. Okay, so add existing items. All right, so this is February 11th now. Okay, and oh, okay, so I'll make this one 10 between 0 and 100. Okay, let's say I have an integer value, okay, and say it has 50 in it. And I have another integer value result, which has nothing, which is 0. Now I want to write this. Take a look. I want to say result is val and then plus equal vi. Okay? I want to do something like this. Now, with what we explained, the left side is always the owner, correct? But the left side is a primitive type. It's an integer. It cannot be owner. It doesn't make sense, correct? But for some magical reason, it is working. So in here, I'm going to say result. And we're going to have val. Okay? When I run this program, we'll see that it actually works. Its res actually became 60. Take a look. You see that? Res actually became 60 because I had 50 over here and I had 10 over here, so plus equal. So it works. It's crazy. And even if I do this, take a look. If I run this, it'll work. Right? And oh, and even take a look. What the heck? They're all working perfectly. Why? Can anybody tell me why these are all working perfectly? I have a kind of a guess on it. There we go. On why is this thing is working nicely where it's not supposed to? I did not. First of all, there is no operator overload. I cannot make minus a member of val because val is not an integer. Secondly, vi is not even an integer. How is it doing it? Can anybody guess? Okay, so for that, I have to ask you this question. And let me take this end out in here. I'm gonna bring it over here. Okay, so if I have that double D over here and I write res is set to val plus equal D, what's going to happen? Actually, you have the microphone. What's going to happen? Go use your IPC 144 and analyze that line for me. I have val as 50, and I'm saying val plus equal D, and D is a double. What is going to be the outcome? What you're going to have in D? Sorry, what you're going to have in val? Val will have the value?
Of 70?
70. So where that 0.2 goes?
Because it's an integer, so...
Because?
Because the val is integer, so...
Yes, val is integer, so D, what happens to D? Do you remember? You know it's happening, but could you please pass the microphone? Tina, what do you think?
It's being casted into integer?
It's going to be casted to an integer.
Yeah.
Perfect. So we know that when two things are being worked with, it tries to make the other one something that it can work with the left one, right? Okay? So D will be casted to an integer, or however that we want. So if that's the case, now please take a look at line number 14 and apply the exact same logic. It means Vi should be casted to an integer, correct? Do we have the tool for it? Did we implement type conversion for an integer for Vi? Line number 29 at left.
Oh, yeah, we do.
Yeah, that's why you review the previous session when you're coming to class. So Vi has the tool for this. And because of that, compiler knows how to fix this thing. Not that it's going to work the way I want to, I don't know, but it's because it's being casted, it's going to work. Okay, it's going to just, so even if I did this, for example, take a look. I'm going to say over here, do I have CSTR here? I think I have CSTR, right? I'm going to copy my include my CSTR. Now take a look. In here, I'm going to say character name, and say put 80.81 over here. See what I'm going to do? I'm going to say str copy into name vi. Why does it give me an error? str copy matches. It should work. We'll see. It should work. I don't know why it's giving me that error. I want to see if it's the. Let me compile and run it. Oh, because it cannot decide which one. Oh, can anybody tell me why? I think it's because it's confused which one to use. Let me see. Let me see if I can do this. There we go. So what happened is that it wasn't that. Because I have using namespace std, and I have include iostream, and in iostream C string is included. So it doesn't know the str copy you're using in main. Is it Seneca's or it's standard C++? So now I'm saying use mine, and it's going to work. Okay? If I didn't have iostream over there, it would have worked perfectly. Okay? So it's kind of confused. It doesn't know which str copy to use. All right? But what I'm saying is right now, you see, it is actually working. So vi over there at right side is not a constant character pointer. But because the tool is provided at line 30, it's going to try and cast it. And therefore, the jar will be copied into name. And when you actually execute, you'll see what happens. You see that? So it actually worked. So these are, I'm saying is that, so I'm going to call it, 01. So I'm going to say, what do I say? What do I call this? Automatic type conversion, or casting, automatic cast call. So essentially it means these are automatically called the casting method of the validated int. Are we okay with this? All right. But now I am going to remove these two. So str copy, I don't care. I'm going to remove the integer one. I'm going to comment it, and I'm going to comment the integer one over here. Okay, look at that. All those things got dead. Okay? Now, the funny thing is that this one says there is no negative, there is no minus. But look at this. So this is actually working. How is it possible? So So I have an xi over there validated int, right? This is perfect. Line number 17 is perfectly okay. Why? Hasti. Why? Actually. Why? Why that thing is working?
Because
Uh,
guessing because the
it's-
xi is another instance of validated int now.
Yeah, so what happens, so let me just run it, and it's not going to work, just letting you know. It's giving me build error, okay? But it doesn't give me an arrow with it. Why? VI is an integer, right? C++ won't compile it, but IntelliSense will not. If it was C++ 90, 99, or if it was C++ 11, it would have compiled and run, but it would crash. Why? This is an integer, right? We know an address is an integer value, right? So in here, you have a constructor that you can create a validated int out of an integer, essentially. So it would actually create a temporary nameless validated int out of this and run it. Crazy. Because it tries to cast it. Cast happens in two different ways. Either you do type conversion, or you have a value that can be passed to a constructor of an object to create a temporary nameless out of it. They are both casting. So that would work too. So crazy stuff, like you can actually do this. And this should work because it is a constant character pointer and it tries to make a temporary nameless out of it. So all these things may work. You got to be careful about it. But that's not the case I want to make. Let's go back to what we had before. Tina's face is amazing. It's like, what the hell are you talking about? Okay. Okay. So I'm going to just clean it up like this. So I can actually start making a point. So I'm going to have, oh, not like that. Sorry. Let's do it like this. And sorry, I have to. Shut the notifications off. OK, so let's do it like this. This is better. So these two cannot be implemented, cannot work, because at left side I have a primitive type, and I cannot overload a member function in here. That's when helper functions come to play. So operators must always, 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 in first attempt, try to be implemented as member operator overloads. If there is no way to do it, there are only two possibilities. Number one, at left side, you have a primitive type that you cannot have a member in it. There is no class at left side. Left side of the thing is a primitive type, a double, an integer, something that you cannot. If that's the case, then you create what we call a helper function. What is a helper function? A helper function is a non-member, stand-alone function that is designed to work with a class. We call it a helper function. Essentially, all functions you have written in C, they were helper functions, because you had functions, you passed structures to it, right? In here, in exceptional situations, you can use it. The design is correct. But if you use it when you don't need it, although it compiles, but it's wrong. Okay? So let's do this. What are we doing here? So if you create a helper function for an operator the operator will look like this. Res is set to operator. It doesn't belong to anybody. Plus equal. At left side, it gets the value, and at right side, it gets the left operand, and at right side, it gets the right operand. So I have to implement that, and that will cover it. How do I do it? So it's returning an integer, operator plus equal. It has side effect. So the left one must be able to change. Therefore, it will be an integer reference, left, operand. And at right side, I have a VI that is not supposed to change, correct? So I have to say const validated int reference right operand. And that's it. So this essentially becomes your operator. And take a look at it. You see that? The error is gone because now it has the prototype. It thinks it's there. You can actually compile it without running it. Okay? You can compile the code without running it. Anyways, compile prg.cpp without executable. It compiles correctly, but it won't execute because it doesn't have the body of plus equal. And same thing over here. What do? I need to say, oh, this is not xi. We can make it xi. You want an xi or want an integer? Let's do integer. So I'm going to say res over here. So in here now we need to have something like res is equal to what do? Operator, and left side is val and right side is vi, correct? So that's how it's called, which means in here now I have to implement it as follows. I have to say integer operator minus, it's a binary, left side. Am I having a side effect here?
No side effect.
No side effect. So there are two choices. Either I can pass a constant reference or I can pass by value. It's an integer. It's a small thing. Why pass a reference? If it was an object, I would have passed a constant reference. But because it's just an integer, I just pass it by value. And for the right side, obviously I do not have any I don't have side effect to the right, most likely, but obviously, and that remains like that. So as you see now, that doesn't give you an error. Now, pay attention to this, please. Extremely important. So to implement these, as you see, they are not member functions. I can just bring these over here in my validated CPP and implement it inside the namespace, but as standalone functions. And obviously, I don't want to have long names because left operand, let's call it, and the other one is going to call it right operand. Because I'm coding, I don't want to type long stuff. For the name, you always are descriptive. But for the what should we call it? The variable names, the argument names, in implementation, you don't need to be that descriptive. Okay? Now, all I need to do over here is to say LO plus equal. Now I need to gain access to the value inside RO. Do I have any tool that provides that for me? Get, right? So I'll go over here, ro.get, and I'm returning LO. Done. Okay? That's a helper operator overload. Now, what are friends good for?
Share.
Huh? To cheer, right? What else? What do you use a friend for? To share a burden? That's fine. Wow, you're all very philosophical today. Friends are usually over there to help, right? Like you're going for a trip, you want to water your plants, you give the key of the house to a friend, say please, or feed my cat or something like that, right? And then you go and you come back 3 weeks later, or 2 weeks later, or 3 days later, and you see your grandma's ring is missing. Then your beloved BFF becomes a thief for you. Even though you forgot, you actually put the ring somewhere else. But you're sure that your best friend stole from you, correct? Okay. In object orientation, friends are only good for knife in a back. So what is a friend good for? To put knife in your back. You should never, ever use friends, ever. If you ever see anybody use friendship, it means they have bad design unless. Anybody over here has a dog by any chance? I have a dog. Her name is Coco. I love her to death. Anybody? A dog? No? Nobody has a dog? You have a dog? Yeah, but you had a dog, right? Beautiful. So your dog is your friend, right? You're a friend of your dog, correct? You can take your dog to the vet tomorrow and put it down. Are you really his or her friend? You are the dog's owner, not a friend. That's the only case you're allowed to use friendship in object orientation. If you want one class to completely own another class, ownership is friendship. There is no friendship in object orientation. So the example I'm about to show you is a horrible thing to do. Please don't do it. Okay? If we didn't have that get thingy in here, if I didn't have that accessor get, how would I implement operator minus? I had to say return LO minus RO dot M value, correct? To access the M value, right? But take a look. It doesn't have access to it, so I can do this. Bring it to the class and say this is a friend. Horrible thing to do. You should never, ever do it unless I ask you so I can see if you know the syntax. If you are using a function for friendship because if you are creating a helper function and your helper function needs to have access to properties of your class, create an accessor. Create an accessor in your function, in your class that you can give access to that one only. Therefore, and a proper access. So in here, your operator minus can access max value, min value, title. It can access all those things. Although we took precautions and we made it a constant, so it cannot change them, but still can access it. It's like you give the key to your friend to go to feed the cat, but he's going to go through your stuff and look at your photos and look at your closet and see what you have. You don't want that. Maybe they don't steal anything, but you don't want your life exposed to others. It's the exact same thing over here. You only give access to that one. And like we did for the plus equal operator. We okay? So that's what friendship is for. We good? All right. Now, what if I want to have something like this? Res is set to minus VI. I can't, right? I want res to get the negative value out of the thing. I want it to extract the negative value. How do I do it? This becomes I could make it a member, obviously. So again, it's a horrible thing I'm doing now. Always your first choice should be to always make it a member. But I'm going to tell you for the next reason, so you'll see why. So how you do this, it actually becomes integer operator minus that accepts a constant VI valid that receives a VI. Let's put it this way. So you can have a member operator created as a helper function too. No need for this. It's just an example. Operator minus constant validated int reference VI. It doesn't accept it? Why? Oh, okay. There we go. So now I can actually implement it saying return minus return. How many times I'm going to return minus vi.get. And done. So it returns the negative value. So you can do binary operators that are a thing, but don't do the following, because operator minus could be a member of VI. But could I make it a member of VI? There is already one that returns validated int, correct? So I couldn't. So that was the only way. I could not make it a member. So don't do this if, do the following, if the operator could be a member of VI. Okay? In this case, it can't. I can't put it inside because the signature of a function is its name and its arguments. And because it is the same, it's not going to work out. So this is the only way of doing it. We good? Okay. So this is helper operators down to this point, 0, 2. In the notes, it says helper functions. Function operator, potato, potato. Call this operator negative, and it becomes a helper function. So when I say a helper function, essentially it means like add. That's the helper function now. So when we say helper function, helper operators, potatoes, potatoes, don't think they are two different things. I'm teaching them both now. We understand this? We okay? Now, we have done all this. Beautiful. Good. Oh, did I rename? I saved the wrong thing. Did I? Yeah, it was this one that I was supposed to, not that. I saved the wrong thing. So I wanted to save PRG, and I did that one. Why is it still giving me an error? Also, it matches two different ones. It doesn't even allow me to do this. There is a way to call it, but forget about it. I'm not going to explain it now. We'll talk about it later. Yeah, you have to explicitly call it. I'm not going to do that now. So I'm going to say, imagine this is not there. That's 3, 4, 5. I'm not going to explain it now. It's a new, just trust me, it's 3, 4, 5, okay? But you just needed to know, that's why I'm putting it over there. So I'll remove this one just to make this work. All right, so that's that. Because in here, it doesn't know which one to call. It doesn't, although the implementation are different in two different ways, but the signature of calling is the same. Later on, you'll find out that you can actually fix that, but not now. Okay, so that's that. Okay. As you see, operator overloading is not like a walk in a park. It's really something that you have to think about it, and when you do it, you have to think about all the different aspects that you're going to take. Now, the next thing would be this. What if I have my validated int is vi? What if I want to do this? First of all, it is working for some reason. If I run it, it says my validated is jar. Remember, the compiler always tries to make your code work because cout is overloaded with constant character pointer. It can cast vi to constant character pointer and print it. This is my heaven for walkthroughs. So I can put something like this and do a walkthrough and say, what is the output? So you have to decide what's going to happen. If that's not what I want to do, I can always overload it. Now, remember about cascading effect? Who has the microphone? Could you please pass the microphone to someone else? I don't know. You're the person behind you. So when this happens, what is the outcome? Every operator returns something. When I say we know that this plus gets B and C, does something to it, and returns it. And therefore, A can be set to that, right? Now, my question is, do you know what is the return value of this operation? Because it has to return something so it can print VI after. So my question is, what does this return? Do you know?
No.
It returns cout. Okay, pass it through to the gentleman over there. So this operation returns cout. That's why the next one can get printed. So I want to be able to do this. See out. Make it easy. So now I have an operator that I need to overload. What is the type of the object that left? What is the cout as class? Do you know? Cout is an O stream. Okay? Cin is an I stream. You can pass it to the next person. Cin is an I stream, correct? Now, at left side I have cout. At right side, I have VI, and it's supposed to return a cout. So essentially, the function I have to overload is I have to go to OStream, hack the code, and add an operator insertion that accepts a VI, so this thing can get printed, right? So I can custom print it. I can print everything in it. But I can't do that because I don't have access to the source code of OStream. This is the second case and the only other case that you can use to write a helper function. So now this is supposed to return a cout, which is an OStream reference, obviously, and it's an operator insertion, and at left side it receives cout, and at right side it receives VI. This is what I need to overload for this to work. Because this is an operator, and I want to write a helper operator that receives a cout at left and a VI at right, and returns cout again so the printing can continue. To do that, that's exactly what I'm going to do. So I'm going to come over here. Let's put this one over here. And this is standard. You should be able to do this with your eyes closed. Okay? So it should return an OStream reference. Obviously, because I am inside here, I have inside a header file, I have to include IOStream. And because I'm in a header file, I am not allowed to do this. Remember, you are never allowed to use the statement using inside a header file. Why? Because if you do that, anybody including that header file will start using that namespace without knowing it. If somebody includes that one, they're going to start using namespace std. Exactly the problem that happened in here. Remember? When I included it, my str copy didn't work because I was using namespace std. Okay? Same thing over there. So you've got to be careful about it. Now, OStream, it's going to be operator insertion, OStream reference, OSTR, name it something. That becomes the name of your cout. And at right side, I have a constant. What is the name? Constant validated int reference right operand. Correct? That is standard. For any class that want to get inserted into OStream, you do this. And it's a helper, so why is this doing this? I don't know. Am I making a mistake somewhere? I don't know. We'll find out if it's a bug of IntelliSense or I'm doing something wrong. So I'm going to create it. Let's bring this thing up. Okay? So, now, what do I do in here? I look to see if I have anything that can display the object. It can, right? I'm going to correct my display. So from now on till the end of OOP345, any display or read should work as follows. You don't write a void display. You write a display that returns an O stream and receives an O stream. Oh, shoot, I hate this laptop keyboard. I cannot work with it properly. Where did I go? There we go. You make it O stream, reference, OSTR, and by default you make it cout, which essentially means, obviously I have to say STD. The syntax didn't, the usage didn't change. People can still call your display. People can still call your display the same way they did before, but the difference is that when you are implementing it, you're going to make the O stream flow through your function as it's getting printed. So you're going to write the display exactly as we mentioned over there. So that's O stream, reference, and in here is going to be O stream, reference OSTR. All you need to do, instead of cout in here, use O stream. And you're done. It doesn't make any difference. OK? And then at the end, you say return O stream. So O stream passes through your function and returns everything out. And your implementation of the operator overload will be after this, as simple as this. Return write.display. And you pass the O stream to it. Done. This is standard. You need to remember that you have to always do this. Now, if I want the users to be able to enter this from cin, I haven't designed anything for it yet. Why is it giving me that? Is it too? Did I make any mistake in here, or it's again? Oh, yeah. OK. Let me see what it's going to do. OK. Anyways, I just forced it to realize that it's there. Anyways, so if I wanted to overload iStream, what do I need to do? I need to have std, iStream, reference, read, scan, whatever you call it, std iStream, reference istr equals to std cin. Obviously, this is not constant like the other one, OK? Because you are changing the object. Now, what is the extraction operator? It's exactly like this one, but it's iStream, istr, and this definitely is not constant because you have to modify it. And then this is extraction operator. And the implementation, oh, sorry, I have forgotten to put the STDs here. It's not going to work. Control-C. Yeah. So what is the implementation? Exactly like the other operator. There's a reason that I'm copy-pasting it. So you see they are exactly the same. This is extraction, istr, and it's not constant. So in here, you're going to say return read of istr, and done. OK? Oh. Now, all I need to do is to implement. Why is it giving me an error? Oh, because it's O stream, I have to make it I stream. There we go. So now all I need to do is to implement read and read it from ISDR as if it's CIN. So in here I'm going to say, for read I'm going to say ISDR I'm going to say cout title. And then I'm going to say ISTR ISTR.getLine because I want it to be including spaces if I want to. So ISTR in M title up to 50 characters. And backslash n is that one, so that's going to get that one. Then I'm going to say cout value. Then I'm going to say ISTR into whatever value, M value. Then cout range. Or I'm going to say min value. And I'm going to go same thing over there, ISTR, min value. And the same thing as max value. ISTR. Now, at the end of this, either one new line is there or more. I'm going to say ISTR.ignore and backslash n. So any garbage after that, throw away. So what happens if user enters something that ISTR cannot read? Then it's going to fail and it's not going to work anymore. And user can detect it later. I simply say return ISTR. And I'm done. So now in my program, I can literally say VI is my validated integer, and it's not going to call the cast anymore because I implemented something that matches before casting. Casting only happens if the action is not available. So therefore, when I run it, if I don't have an error, wow, I didn't have an error. Cool. So it comes over here. And as soon as it reaches when it gets executed, it goes to O stream, goes to display, shows all the stuff that it's supposed to show, comes back, and if you look at it, now it is printed. You see? Title, yada, 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 is my validated integer. Bad. Why? I have hidden logic in my display. The display is not supposed to go to new line. The job is only to display that line. So I'm going to fix that. I'm going to go to my display, remove the end L at the end. If they want to, because it's going to be used, it is returning O stream. If they want to go to new line, they're going to do end L. So now it's going to actually work properly. If I run it, it's going to actually show it as title jar yada yada is my validated integer. So it actually shows it exactly as it's supposed to. If you remove it, it's going to cast it and only show the jar thingy. We good? That's all about helper functions and input and output customization. Okay? Remember, in your display and in your read, do what it's supposed to do only and nothing extra. As you see in a display, I had an extra new line, which wasn't necessary. Display's job is to it's supposed to show the object, not to go to new line. Maybe they don't want to go to new line. So don't do that. Only do what is needed, and you are fine. Are we good down to this point? The class ends at 12:30, correct? Or 12:25 or so? 12:30? Okay. So let's have like 5 minutes break, and then we come back and we're going to learn something cool. I'm going to pause this. So to find out exactly what is in your test, go to the subject. It will be in the agreement. An agreement of midterm, I'm going to post it tomorrow. So all the agreements are going to go up for the midterm. So you will see exactly what's going to be on midterm and so on and so forth. But I'm going to explain it anyway. So you go to your subject page. OOP244. I just want to make sure that I'm not going to do something that is not going to happen by mistake. I want to make sure that it's good. Okay. All right. So you go to course information, addendum. 3 years later, you log in, and then you scroll down. Week 1, 2, 3, 4, 5. So member operators, the current objects, that's it. Helper functions and operators are not going to be there. So member operators are the last thing that you're going to be questioned on. Okay? First 5 weeks. So no input output. Take a look at, so because when it says member operator, just go to the, so essentially it's right down to here. This is the last one. Okay? Member operators. I want to see if we have any input output over here. No, there's nothing there. Anyways, yeah, so member operators it is. And when you are looking at the sequence, careful, because let me show you this. Careful, because we changed an order in here. So when you are looking at your addendum over here, the addendum for week 5 is member operators, current thingy, and that's it. Classes with resources are showed before this, but it comes after the study break. So careful. That's not in your questions. So classes and resources are the thing we're going to understand the first week of that. Okay? We good? Classes, resources? It means you're not supposed to. I'm going to teach it after the break. So only first field, this is coming after. So only the topics that you see over here. You can match the topics to what you have in your in the notes. Yeah, so if you go to here, so so it's literally tells you what this is 244, yeah, right. So current object, member operators, and that's it. That's going to be the last thing that you're going to be studying. It's not going to be after that, okay? Don't go for classes and resources. It's right down to here. This is the last one. No helper functions, no input output operators. They're not going to be there, okay? That's that. Resume. Okay. So we talked about inheritance. We said inheritance is essentially reusing a class as a design, right? So we said we have a vehicle. Out of a vehicle, we create a car, and out of a car, we make different types of car. we have a pickup truck and stuff like that. We create, again, bicycle, motorcycle. We reuse all the definition and designs that we had before. Therefore, we don't have to re-implement it over and over. And everything that work with the base class work with the child too. Okay? So if I tell you ride a bicycle, you ride a bicycle. If you ride a motorcycle, you ride a motorcycle. Although acceleration is different between a bicycle and motorcycle, but steering is the same. Brake, almost the same, half of it. But yeah, so what I'm saying is that essentially you get something that you have and you add features to it. So we have I/O stream. I/O stream essentially is something like this. With I/O stream, there are several different classes. We have a mother class at the top that is mother of all. Then we have two classes inherited out of that one. So the top class, we call it I/O stream, iOS. iOS holds all the basic things that are needed for input and output systems. Everything that you have. Okay? Then out of I/O stream, two classes are inherited. One is called O stream, and the other one is called I stream. O stream is the one, O stream is the one C out is built up of, is created. So C out is an instance of O stream. C in is an instance of I stream. Why didn't they create, actually I stream and O stream, their constructors is private. You cannot instantiate them. Crazy, huh? So how come I have O stream and I stream? The reason they do that, it's called kind of a singleton. A singleton is an object that you can only instantiate one thing out of it. You cannot have two of it. I stream is a simple sample of that. When you say I stream, when you say get something from input, that's your keyboard. That's it. So you have one C in out of it. You cannot make two different ones because you don't have two keyboards. You have one keyboard. Same thing with the screen. If you're printing something out, you're printing out. Now, obviously, to make sure everything works, they have few more. Yeah, they have C error and C log. So C log and C error, C ERR and C AOG, they work exactly like C out. Why? If C out fails, you can still show your error messages on C ERR. If you want to do debugging, you can show it on C log. So if you want, you can disable C log, so only your debugging messages will disappear. Everything else will work. Things like that you can do. But again, those are created inside the I/O stream header file. That's why anywhere you include it, these global objects become available, right? They said it's pretty cool how we can print on cout, and it's pretty nice how we can get from keyboard. I wish we could do the same thing in files. We could write the same way we wrote on a screen, but in a file. I could read the same way I read from keyboard, but from a file. So what they did was actually creating two more classes over here. These two classes are called IF stream, which is a child of O stream, and then OF stream, which is a child, oh, sorry. My apologies. OF stream, which is a child of OF stream, which is a child of O stream, and IF stream, which is a child of I stream. And then they said, okay, so OF stream, fine, it writes in files. IF stream, it reads from files. But unlike C in and C out, sometimes input and output could be the same file. You can read from a file, and you can add to the end of that file. Or go modify a file while reading, searching for something, you want to modify the file. For that, they say I should be able to read and write into the same file. For that, they actually created another class, and they call that F stream. So IO stream inherited into these two. OF stream is inherited to here, and F stream is a product of the two. It's called multiple inheritance. C++ is one of the few languages that have that capability, that has that capability. You cannot do this in other languages, object-oriented languages. So we know that you cannot instantiate I stream and O stream, but is it the same thing when we are dealing with OF stream? OF stream cannot be one file. You can have 50 different files. So you have to instantiate it. First of all, they named all the header file that contains all the definitions of IF stream, OF stream, and F stream. They put it in one place. They call it F stream. So if you include F stream, you're all good. Now, I can say OF stream, and in here I'm going to call it a file. Now, if you want to create a file, what would you pass to its constructor if you wanted to design it? What identifies a file on a hard drive? The file? Path of the file doesn't identify the file. Path can identify 5,000 files. The extension identifies what type of a file it is. It doesn't uniquely identify the file. You're doing a good job, by the way. So what identifies a unique file on a hard drive? What everybody's thinking?
Name?
Huh?
Name?
Name of the file. For heaven's sake. Thank you. 1% for midterm. Okay? Seriously, you have to remind me of it. Okay? So, name of the file. So that's what you do. You say file name, and in here I'm going to say report, or I don't know, data.txt. Okay? And that file is a child of, or I'm going to call it output, is a child of O stream, right? So it's the exact same thing as C out, correct? So take a look. Done. If I compile and run this program, the output will be nothing. First of all, this is huge. Give me a second. Bothering me. Properties. Okay, that's better. The output is nothing. But if I open, you'll see there's an output.txt, and inside you have what you print. So I don't need to teach anything. You know how to write on a screen? You write like that in a file. As simple as that. So let me give you an example. Let me give you an example. Give me a second. Let's say I have series of student names in a file. The name of the file, comma, student number, comma, GPA. Right? If that's the case, how am I supposed to read it? You have to imagine that there is someone typing all those things on a screen. How would you read it? I would read everything up to a comma, throw away the comma, read everything else up to comma, throw away the comma, read everything else up to new line, throw away to the new line, correct? Right? That's exactly what you're going to do. So I'm going to right off the bat write the object-oriented version of it. I'm not going to write the, you'll see. So those are student information, right? So I'm going to call it this class student, right? A student has character name, let's say 81, or I don't know, 51. Let's put it that way. And I'm going to make it empty by default. Empty by default. And then I have a student number, right? Empty by default. And then I have a float GPA, empty by default. Now, because I'm doing it object-oriented, I want to follow the rules. I'm going to go M underline, and M underline, and I have no idea what is that. There you go. Okay, public. Okay, do I need a constructor for this? No, I'm not going to write anything. When you don't write anything, it will create a default constructor for you. As soon as you create a constructor, you have to do it all. Okay, so I'm not going to touch it. Let it is created, and it's going to put blanks everywhere. Now I want to be able to print it. So I'm going to say OStream reference print OStream reference OSTR equals to cout, right? Correct? Now what do I do in here? I'm going to say cout. Name is 50, so I'm going to say cout.width. I'm going to put over here 50. I'm going to say cout.fill with dots. Now I'm going to say cout.setf iOS. See, in iOS is the mother. I have left over there, so it's going to be left justified. And I'm going to say cout m name. Done. Okay, m name is printed. Immediately, I'm going to fix those two values back to its original. So go back to space and unset left. Now I have it. Now I want to print the student number. I'm going to do the same thing over here. So cout.width. Say 9, I don't know, 8. I don't know how many student length was. I'll set it later. And cout.fill. I'm going to put 0 at left side, and it's going to be right justified. So in here, I'm going to say cout.setf iOS write, and C out what is that? Student number, and obviously I'm going to unset it back to what it was before. cout.unsetf iOS write. Okay, and cout.fill to blank again. Okay, now I'm printing the GPA, so it's got to be cout.precision, and I made a mistake. I'm going to fix them all. These are not supposed to be cout. These are supposed to be OSTR because I'm printing on OSTR. But obviously, anyways, precision, I'm going to make it 1 because it's GPA, and cout.setf iOS fixed, so it doesn't have different type of things, and GPA is always the same, so I'm going to say cout mGPA. Do I have anything that I need to fix? No. So the only thing I need to do is to change Control H, cout to OSTR, and in this block. Doesn't have block? And I'm going to say in current document. Current document. Do I have cout anywhere else? No, I don't know. Anyways. Now I'll fix this OS to cout. Okay. Cout. And I'm done. Okay? So, and at the end, I'm going to return cout. Return cout. Sorry, OSTR. Now for reading, what I'm going to do. First, let me clear this thing up so we can see what we are doing. Okay. Split the window so I can see what I'm reading. So I'm going to have iStream, reference read, iStream, reference ISTR, by default is cin. Now let's write it. So first I need to read the name. So I'm going to say cin.getLine into name up to 50 characters, 51, and stop and dump. Stop at comma and dump it. Then I'm going to say, now it's dumped, I'm going to say cin into student number. I'm reading the student number, right? Now cin.ignore. Done. I'm just going to ignore that one comma that is coming after. Now I need to get the GPA, correct? cin mGPA, right? Now after that, it stops. I'm done. So I'm going to say cin.ignore. I don't know, 10,000 characters and a \n, whatever. So go to the next record and return cin. And again, I made a boo-boo. It's ISTR, not cin. Correct? All right? Now, am I writing it for F stream? No, I am receiving it I stream. It's not IF stream. Why? My name is Fardat. If you're crazy enough, you can call me Mr. Soliman, but I will still answer it. Why? You can call me by my parent's name. Correct? So any child can be called by their parent's reference. So I don't need to write it for F stream. I'll write it for I stream, and it works for both. You'll see. So now I have to overload this so it can work with anything, right? So, and I told you, eyes closed, you have to do it. O stream, reference operator. O stream, reference OSTR, and const student reference other, or write. And I got to make sure make this a constant because it's not supposed to change anything in here. Now, operator. All right. Now in here it says return write.print and pass OSTR to it. Done. Okay. Again, iStream reference operator extraction iStream reference ISTR, and it's going to be student reference write because I need to change it, and it's I'm going to say return write dot read OSTR, and done. Oh, ISTR, sorry. Now, what do I need to do? I need to say ifstream in file student dot CSV, correct? So that's my file. Now, we know that cin is overloaded for Boolean type conversion. So I can simply say while in file. It means if it's open or everything's good and life is beautiful. Now I'm going to say in file, and I need a student somewhere. Where's my student? So in here I'm going to say student s. So in here I'm going to say in file s. Okay? So it's going to read into the student. Now if everything is good, if in file didn't fail, if it fails, I'm going to know, right? If it didn't fail, then I'm going to say file into file write yes, and go to new line, and let's put it on output 2, and go to new line. And done. I don't need to do anything else. Why? Because it's object-oriented. I don't need to close a file. It has a destructor. They closed it already in there. If you want, you can manually close it. If you want to reopen it, I can say over here in file.close. Anything that you guess, it's going to be there. But you don't need to because it has a destructor. If you wanted to reopen it, sure, with another file. But if that's the case, then that's the case. So all I now, I'm going to just run it and see. Hopefully it works or breaks, or I don't know. So it runs, and there you go. This is my, oh, I forgot to put it. See, the output is actually showing those things. Let's fix that. So in here, let's add, where is that thing? Student number. And I'm going to put a dash over here. Let's do it that way. And then semicolon. Run it one more time. This is on a screen. This is in a file. Potatoes, potatoes. You can do anything you want with a file the way you use iStream and OStream. OK? Files, done. That's a good thing about object-oriented. I don't need to teach it, because we already talked about seeing and see. Hopefully you saw that video, the session that we missed. OK? Please. OK? Go. You didn't see it, did you? Did you see it? Please go. It's a session that it shows you how to format and how iStream and OStream works. You have to see that. Huh? Yeah, it was recorded out of class. It is in your playlist, and you have it, so it's here. So if you go to, I'll bring it up. So it's, there you go. So these are the examples for it. So it's, what the heck is this? Well, I don't know, what is that? Oh, that's my compilation. Anyways, so it's right over here, okay, with all the things that you need to know. And that I put the video of it in the YouTube. So you can go on YouTube and see the video too. It takes like an hour, and it explains exactly how input-output works in C++. Okay? That's it. Questions? We good? All right. We are almost done with all the bells and whistles that we need to start actually doing object-oriented programming. Down to this point, we just showed you encapsulation and a little bit of overloading and stuff. As soon as we come back from the break, we're going to get into serious stuff. Memory management with, so we're going to learn about how two objects, when they have memories outside their scope, how they're supposed to be copied and assigned to each other. It's called rule of three. And then we'll talk about virtuality, templates, and things like that. These things you learn. So you learn all the concept of C++. And next semester when you come back in 3, 4, 5, we're going to use the syntax to learn C++. 2/3 of C++ are the tools that C++ has. 1/3 is the syntax. So we learn all these things so we can use all the tools. So 3, 4, 5, if you learn the 244 properly, will be an extremely easy subject. If you don't learn 244 properly, it's going to be your nightmare. Because over there, I'm going to talk about things that inherit from each other and templates that do this and that. And because you didn't go through 244 properly, you have to say, what the heck? If you don't do that, believe me, 3, 4, 5 is going to be a breeze. Okay? Questions? Suggestions? Objections? So this time I'm going to save this.